Describe briefly with the help of a circuit diagram the method of measuring the internal resistance of a cell. Okay. Now we'll see the circuit diagram here. This is the circuit diagram. Here the resistance is given, the battery is connected, and the secondary circuit is there. Here the resistance with known value and connected to the battery, and it is connected to the galvanometer with some distance of the wire, and EMF is also there here. Then we can see the K1 and K2 are the plugged and unplugged. Then what will happen here, we will see here. Okay, let's see the difference here. When plug in the K1, when the K1 is plugged, that means it is on, and by that time the K2 it is in the off condition. Then find the balancing length of L1. You can find the balancing length of the L1 such that E is equal to K times L1. E is equal to K times L1. With the key K2 also plugged in. Now the K2 is also plugged in. Then find out the balancing length L2, which is given by, then we can find here balancing length L2, which is V is equal to K times L2. Then we know that where R resistance R been defined, R is equal to E by V minus 1 times the known resistance R value. Then the unknown value R with the help of the L1 we can find L, that is the length, L1 by L2 minus 1 with the help of the known resistance R value. In this way we can find the resistance of a cell of the unknown resistor. Then second part, give reason why a potentiometer is preferred over a voltmeter for the measurement of an EMF of a cell. Okay, we'll see why it is like this. Because the potentiometer is preferred over the voltmeter for measurement of an EMF of a cell, because potentiometer draws no current from the voltage source being measured. For this reason, we are going to prefer potentiometer over the voltmeter for the measurement of an EMF of a cell. Okay, part C. In the potentiometer circuit given below, calculate the balancing length L. Give reason whether the circuit will work if the driver cell of EMF 5 volt is replaced with a cell of 2 volts, keeping all other factors constant. Let me zoom this diagram. It will look like this. Okay. Here then we can find the value of V here like this. Okay. The given data here it is for the C. The given data is V is given, that is equal to 5 volts, and RAB, resistance AB, is given as 50 ohms, and R value one more that is given, that is 450 amps. Okay, then we can find the I value. I is equal to 5 divided by 450 plus 50. 450 plus 50 is equal to 500. Then 5 divided by 500 is nothing but 1 by 100. 1 by 100 we can write in terms of decimal, that is 0.01 amps. Okay, then VAB is equal to 0.01 times 50. We will get the value, that is 0.5 volts. Then K value is equal to, that is 0.5 volts, that is VAB, divided by 10. We get the value 0.05 volt per meter, because the VAB across the length 0.5 divided by 10. Then K value, then length L is equal to V divided by K, then 300 into 10 to the power of minus 3 divided by 0.05, we will get the value 6 meter. We get the value, that is 6 meter. Then with the 2 volts, driver cell current in the circuit I, for 2 volts, I is equal to 2 divided by 450 plus 50, that is 500. Then 2 by 500 is nothing but 0.004 ampere. Then the PD across AB is 0.004 multiplied by 50. 0.004 multiplied by 50. We get the value that is equal to 200 mV. By this value, we can say that hence the circuit will not work according to this given data. Okay. Next, here one more different question they are given here. That is the second part. State the working principle of a meter bridge used to measure an unknown resistance. Okay. Here the meter bridge is based on the principle of balanced Wheatstone bridge. Okay. Next, give reason. First one, why the connection between the resistor in a meter bridge are made of a thick copper strips. Second one, why is it generally preferred to both the balanced length near the midpoint of the bridge wire? So first part here, the thicker copper stripes are used to minimize resistance of connection which are not accounted for in the bridge formula. And the second part, why we are going to use balance point is preferred near the midpoint of the bridge wire to minimize the percentage error in the resistance. Okay. Then the third part, calculate the potential difference across the 4 amps resistor in the given electrical circuit using Kirchhoff's rule. Okay. Let me draw this diagram once again. It will be looks like this. Okay. And with this diagram, if I am going to solve this question, the same. Okay. Here it is there I1. Here the I1 and I2 is there in this direction. This is the I1 and here it is I2. Okay. Then we know that I is equal to I1 plus I2. In the loop ABCDA, in the loop ABCDA, then I am getting the value that is minus 8 plus 2 times I1 minus 1 into I2 plus 6 is equal to 0. If I am going to take this is the equation number 1 and a loop ABCDA, I will take this value is a loop number, means equation number 2. Then in the loop DEFCD, then in this case I am getting the value that is a minus 4 times I minus 1 into I2 plus 6 is equal to 0. Then I am going to simplify this one as 4I plus I2 is equal to 6. Then 4 times of I1 plus I2 plus I2 is equal to 6. Then 4 times I1 plus 5I2 is equal to 6. This value I am going to consider as equation number 3. Okay. Now from equation number 1 and 2, I am getting I1 is equal to, from equation number 1 and 2, I am getting I1 is equal to 8 by 7 A and I2 is equal to 2 by 7 M. Then I is equal to 10 by 7. Potential difference across the resistor 4 amps is V is equal to 10 by 7 times 4, that is equal to 40 by 7 volt.